In this section, section 5.8, we will be solving radical equations and inequalities. First, we're going to take a look at radical equations. What that is just equations with radicals that have variables underneath the radicals. Now to solve, first we want to isolate the radical. Once we isolate the radical, then we will raise each side of the equation to a power equal to the index of the radical, which will ultimately eliminate that radical. Example 1, I want to solve the square root of x plus 1 plus 2 equals 4. First, I need to isolate the radical by subtracting 2 from both sides. So I get the square root of x plus 1 equals 2. Since my index is 2, I'm going to square both sides. Now, squaring a square root cancel each other out. So on the left side, I'm left with x plus 1. And on the right side, I am left with 4. So then I finish the problem, and I get that x equals 3. Now, with these problems, we must check our solution. So, is the square root of 3 plus 1 plus 2 truly equal to 4? So I get the square root of 4 plus 2. So if we can continue to simplify, the square root of 4 is 2 plus 2. That truly does equal 4. So my solution of x equals 3 is correct. The reason we have to check is sometimes we will have extraneous solutions, and that is when I obtain a number that does not satisfy my original equation. Example 2, solve the square root of x minus 15 equals 3 minus the square root of x. Since there's no way I can completely isolate the radical, what I'm going to do is just start by squaring each side. Now when I square the left side, I have the square root and the squared, so those cancel each other out. So I'm left with x minus 15 equals 3 minus the square root of x times 3 minus the square root of x. On the right side, we must FOIL that out. So then I get x minus 15 equals 9 minus 6 square root of x plus x. Now, since I only have one radical left, I want to isolate that radical. So I will move everything else to the left-hand side. So by isolating the radical, I get that 4 equals the square root of x. Once your radical is isolated, square both sides. So I get that x equals 16. Now remember, you have to check your answers. So I want to check that the square root of 16 minus 15, does that equal 3 minus the square root of 16? 16 minus 15 square root is 1, so I get 1 on the left-hand side. Then I get 3 minus 4 on the right-hand side. So 1 does not equal negative 1, which means my solution is not a true answer, which means that this problem has no solution. Let's try another example. Example 3, solve 3 times 5n minus 1 to the 1/3 minus 2. You can rewrite this so it's in radical form. Now I simply want to isolate my radical again. So I get the cube root of 5n minus 1 equals 2/3. Now to get rid of my cube root, I will cube both sides. Which gives me 5n minus 1 equals 8/27. Remember, you can cube the numerator and cube the denominator separately. Then solve for n. So I get that 5n equals 35/27, which gives me that n equals 7/27. Now, I must check my answers. So 3 times 5 times 7/27 minus 1 to the 1/3 minus 2. So I get 3 times 35/27 minus 1 to the 1/3 minus 2. So I get 3 times 8/27 to the 1/3 minus 2. Then I get, after taking the cube root, I get 3 times 2/3 minus 2. Which leaves me 2 minus 2, which is 0. So n truly does equal 7/27. Next, we will take a look at solving radical inequalities. That's an inequality that has a variable under the radical sign. If my radical is an even power, such as the square root, the fourth root, the sixth root, I must first take whatever is under the radical and force it to be greater than or equal to 1. So 4x minus 4 must be greater than or equal to 0. So I have 4x must be greater than or equal to 4. So x must be greater than or equal to 1. Now I'm going to solve my inequality like normal. Isolate the radical and then square both sides. So I'm going to have the square root of 4x minus 4 is less than or equal to 4. Then I will square both sides to give me that 4x minus 4 equals 16. 4x equals 20, so x equals 5. Excuse me, less than or equal to 5. At this point, we will use the number line with the two answers that we have to test our intervals between those answers. So my third step, I need to test between when x is 1, when x is 5. So that breaks my number line into 3 areas. Something that's less than 1, some number that's between 1 and 5, and some number that is bigger than 5. I must find a value in each of those intervals and test them in my original. So if I let x equal 0, when I test x equals 0, 2 plus the square root of 4 times 0 minus 4, I get 2 plus the square root of negative 4, which I can't do. Can't take the square root of a negative answer. So this is not a solution. Then I want to pick something between 1 and 5. So if I let x equal 2. So I get 2 plus the square root of 4 times 2 minus 4. 2 plus the square root of 8 minus 4. 2 plus the square root of 4. So I get 2 plus 2 is 4, which is truly less than or equal to 6. So that is a solution. And then I test something bigger than 5. So if I choose let x equal 7, then I get 2 plus the square root of 4 times 7 minus 4. 2 plus the square root of 28 minus 4. 2 plus the square root of 24. Now the square root of 24 has to be a little bit smaller than 5. So then 2 plus something a little smaller than 5 will not be less than or equal to 6. So this is not a solution. So it appears that my answer must fall between 1 and 5. So my final answer one is less than or equal to x, which is less than or equal to 5. Now we will try another inequality problem. Let's solve the square root of 3x minus 6 plus 4 is less than or equal to 7. So first, take whatever under the square root, force it to be greater than or equal to 0. So 3x must be greater than or equal to 6. So x must be greater than or equal to 2. I will come back to that value later. Second, I will solve my inequality like normal. So the square root of 3x minus 6 less than or equal to 3. Square both sides. I get 3x minus 6 is less than or equal to 9. 3x is less than or equal to 3. So x is less than or equal to 1. Excuse me, I subtracted 6. I should have that 3x is less than or equal to 15. X is less than or equal to 5. So these are the two values that I'm going to separate my interval into. So I have 2 and 5. So pick a number that's less than 2. Pick a number that is between 2 and 5. Pick a number that is bigger than 6. Test each of these intervals. After testing these intervals, we know that x equals 0 does not work, and when x equals 6 does not work. The only one that works is when x equals 3. So therefore, my final answer has to be 2 is less than or equal to x, which is less than or equal to 5.